Good morning all. Today we are going to discuss about Unit 5. It's named as Power Devices and Display Devices. What is power devices? Power devices is a semiconductor device used as a switch or a rectifier in a power electronics. For example, SMPS in PCs. Such a device is also called as power semiconductor device. When it is used in a integrated circuits, it's named as power ICs. It usually used in commutation mode. What is commutation mode? Commutation is nothing but either the device is used in on or off mode only. They are also found in system delivering as little as a few tens of milliwatts for a headphone amplifier up to around a gigawatts in a high voltage direct current transmission lines. Let me know what is display devices. It is an output device for presentation of information in visual or tactile form. Tactile is nothing but electronic display for blind people. When the input information is supplied as a electrical signal, the display is called an electronic display. Then we are going to discuss about power devices. Firstly, we are going to discuss about UJTs. What is full form of UJT is Unijunction transistor. UJT is a three-terminal device. It consists of lightly doped N-type semiconductor bar. It has two terminal is named as B1 and B2. So B1 is nothing but base 1 and B2 is nothing but base 2. A heavily doped P-type material is injected to the one side of bar, which results in a PN junction. The terminal connected to the PN junction is called as emitter. This is just nearer to the base 2. This N-type silicon bar has a resistance and can be represented as two resistors RB1 and RB2. So this is the equivalent circuit of UJT and this is the symbol of UJT. This resistance RB2 fixed and RB1 is variable, since this value of varies with the operation of a device. The PN junction is represented by a diode. The arrow indicates the conventional current. The arrow indicates the conventional current holds flow when the device is forward bias. The emitter diode is non-conducting. When IE is 0, the resistance between the bases B1 and B2 is represented as RBB. So the total value of RBB is the sum of the resistance between the both bases. So RBB is equal to RB1 plus RB2, which is typically 5 to 10 kilo ohms. When the supply voltage applied to the two bases, the voltage across the RB1 is given by V1 equal to VBB into RB1 divided by RB1 plus RB2. It is given by voltage divider law. So VBB is nothing but the total voltage across the resistance RB1. So the total resistance RB1 plus RB2 is replaced by RBB. So the total voltage across the RB1 V1 is equal to eta into V. So eta is nothing but the ratio between the RB1 and RB2. So eta is intrinsic standoff ratio of the particular resistance. The value of the intrinsic ratio eta is 0.5 to 0.8. Then we are going to discuss about working of UJT. So for working, we can divide the working of UJT is into two cases. First case is VA is less than VA. For this condition, UJT is off state. Case 2 is V greater than VP. For this case, UJT is turned into on state. For case 1, VE is less than VA. The PN junction is reverse bias. In the emitter current IE will not flow. Thus UJT is off. For case 2, VE is greater than VP. For this case, we are going to calculate the voltage VP is equal to VA plus VD. The total voltage VA is replaced as eta into VBB plus VD. So when VE becomes equal to or greater than VP, the PN junction becomes forward bias and the current IE flows. Due to this, charge carriers are injected in the RB1 region of the bar. Due to this additional charge carriers, the conductivity of the RB1 region is increases, that is resistance, and due to the which drops across it also decreases. This makes the PN junction more forward bias, which further increase the current and more charge carriers are injected. So the current IE is increases to the value determined by the source resistance. So for these cases, UJT is turned into on state. Next we are going to discuss about the characteristics of UJT. For the characteristics curve, we are going to draw the graph between the current and voltage between the emitter junction. So VE and IE. For this case, we are dividing the characteristics of UJT into three regions. One is cutoff region, another one is negative resistance region, another one is saturation region. For cutoff region, the emitter voltage VE is less than VP and the PN junction is reverse bias. A small amount of reverse saturation current IE only flows through the device, which is negligibly small in order of microamps. This condition remains till the peak point. Next, we are going to see about negative resistance region. For this region, the UJT is in active mode. When the emitter voltage VE becomes equal to VP, the PN junction becomes forward bias and IE starts flowing. The voltage across the device decreases in this region. The current through the device increases. Hence, this region is called negative resistance region. This decreases the resistance RB1. This region is stable and used in many applications. This region continues till the valley point. Next, we are going to discuss about saturation region. In this region, increases in IE, further valley point current IV drives the device in the saturation region. The voltage corresponding to the valley point is called as valley point voltage, denoted as VV. In this region, further decreases in voltage does not take place. The current is similar to the semiconductor diode in this region. For this condition, the active region, that is negative resistance region, the holes which are large in number on P side get injected into N side. This causes increases in the free electron in the N-type slab. This increases the conductivity, that is decreases the resistivity. Hence the resistance RB1 decreases in this region. Let me conclude the characteristics of UJT. When VBB increases, the potential VP corresponding to the peak point will increases. Then some of the applications of UJT. First is triggering of other devices like SCR. In a sawtooth waveform generator, it also used in relaxation oscillator, in timing circuits, in automobile, in ignition circuits. Then we are going to discuss about UJT as a relaxation oscillator. For this case, UJT is a relaxation oscillator. It generates the sawtooth waveform. It consists of a UJT and a capacitor CE, which is charged through RE as a supply voltage is switched on. The CE is charging and this waveform is denoted as the charging and discharging period of CE. The voltage across the capacitor increases exponentially and capacitor voltage reaches the peak point voltage VP. UJT starts conducting and the capacitor voltage discharging rapidly through EB1 and R1. After the peak point voltage of UJT is reached, it provides the negative resistance to the discharging patch, which is useful for working of relaxation oscillator. As capacitor voltage reaches 0, then the device cut off and capacitor CE starts charging again. This cycle is repeated continuously, generating a sawtooth waveform across CE. This inclusion, the external resistance R2 and R1 in series with B2 and B1 provide the spike waveform. When the UJT fires, the sudden surge of current through the B1 causes drop across R1, which provide positive spike. Also the time of firing, fall of VB1 causes I2 to increasing rapidly, which generate negative going spikes across R2. The charging the value of capacitance CE and RE, frequency of waveform can be charged as desired. Then we are going to discuss about frequency of oscillation. For this calculation of frequency of oscillation, we are going to take a VC as the voltage across the capacitance. So VC is equal to VBB into 1 minus e power minus t divided by RE into CE. So for RE and CE are nothing but charging time constant for resistance and capacitance in this circuit. T is nothing but time from commencement of waveform. So let me conclude. Discharging of capacitors across when VC is equal to the peak point voltage, then we are equate the VP and VC. So VP equal to eta into VB equal to VC value we are going to take as VBB divided into 1 minus e power minus t RE into CE. So from this equation we are cancel the VB and VBB. Then we have the eta equal to 1 minus e power minus t divided by RE into CE. From this equation we are going to calculate T equal to RE into CE log of E 1 divided by 1 minus eta. We are going to cancel the E. Then we are going to take a log. So T is equal to, so we are converting E into 10. So we have the constant like 2.303. It is a discharging time capacitance neglected. So from this T we are going to take a inverse for calculating the frequency of oscillation. So this is the frequency of oscillation UJT as a relaxation oscillator.